Welcome to the HPC Best Practices webinar series. This series is brought to you by the IDEAS Productivity Project, which is part of the Exascale Computing Project, ECP for short, of the United States Department of Energy. I'm Osni Marquez from Lawrence Berkeley Lab, and will be the host for today's webinar, Infrastructure for High-Fidelity Testing in HPC Facilities. The webinar will be presented by Ryan Prout. Ryan is the group leader for the Software Services Development Group in the National Center for Computational Science at Oak Ridge National Laboratory. He's also the software deployment lead for the ECP, Exascale Computing Project. Ryan works with operational staff across labs to provide software integration, continuous integration support to ECP software technology teams. We have issued more than 140 tickets for today's webinars. All attendees have been muted upon entry. We'll never know how many people are going to show up. We'll receive questions. Receive questions through the Zoom chat and also Google Doc, whose address I'll paste the address in the chat momentarily. We have asked Ryan to add breaks during his presentation so he can respond to questions that come in. I'll stop my sharing, Ryan. And please, you go from there.
Oh, I'm muted. Cool. Can you see my screen properly?
Yes.
All right, thank you. Yeah, so thanks, Osni. So my name's Ryan Prout. I'm at the Oak Ridge National Lab. Today I'm gonna, I want to kind of propose a concept more than anything, and something that I personally think is kind of missing in this in some of the workflows we're working towards for sustainable software, connected systems, and things like that. And so. But yeah, as Osni said, my background has kind of been feeding this desire to talk about it more, especially within ECP, but also with my position at Oak Ridge, kind of focusing on software services for the facility. And so we'll talk about what we'll give in the beginning here. I'm going to give kind of like a high level view of a few things at play here. So most of the discussion will be focused on kind of the OSCR facilities, so the Advanced Scientific Computing Research Facilities, the user facilities there for computing. We'll also look at the ECP stuff, so the exascale computing stuff, and I'll try and tie all that together a little bit, and also look at some other things, maybe tie a little bit to the Integrated Research Infrastructure Initiative, and also the software sustainability initiatives coming about next, so post-ECP. All right, and ultimately, my history feeds a lot of this. So I'm not a scientific application developer myself. It's mostly about the software, the operational software around the facility to facilitate workflows and services and things like that. And that's beginning to feed more into kind of these DevOps ideas in the scientific space around these facilities. And so I kind of want to highlight a few things in that space, mostly during this talk. So some gaps that are present, and maybe some ideas to help remedy that. So the goals here, build momentum. This is maybe the main one, is build momentum in creating common CI services across. So CI being continuous integration in this case, services across the Advanced Scientific Computing Research Facilities. And then kind of drawing links in IRI, and then boosting the experience. Talk about boosting the experience for scientific software testing, integration, and deployment at these facilities. And then we'll review kind of how we've been approaching that within the ECP space, and then how we can see high fidelity environments helping with these processes and workflows of testing and integrating software into these unique and advanced environments. And then hopefully we can generate discussion, or keep the discussion going, and contribute to some of these these other ideas happening, especially with the research, software, and engineering efforts, and software sustainability and stuff, as I had already mentioned. All right, so we'll define a few high-level things. So just what are the OSCAR facilities? Not everyone may not know, but they're high-performance computing and network facilities. There's Oak Ridge Leadership Computing Facility, where Frontier is. There's the Energy Sciences Network, which is actually the network kind of data plane that ties all these together. Excuse me. And there's NERSC, National Sciences Supercomputing Center, where Perlmutter is hosted. And then Argonne Leadership Computing Facility, where Aurora is being built. And these are the exascale systems of the future. And then they all have, projects planned for the future as well. So, but these systems get, more and more complicated. The software environments that have to be applied to these systems is getting more and more complicated. And so the ability to provide like a cohesive, software deployment and integration strategy across these is of high interest, especially for the future. And the Exascale computing project has been looking at that issue in particular, but we need to carry forward that momentum post-ECP. And so the Exascale computing project, there's three, just a little background, there's three main areas. So you have application development, software technology, and hardware integration, and they kind of stack on top of each other in that way. So where I've been focusing is in the hardware and integration space, specifically in the software deployment at facilities. And so, facilitating the software deployment to each of those systems at different labs. And so we have operational staff at each lab working with software technology folks, application development folks to bring software to the system. And I guess another important thing to mention about ECP is that it's been a very long running project. And so formed in 2016, it's been here to accelerate the research, development, acquisition, and deployment of projects. And so I think that's an important thing to recognize about how ECP was set up with this long runway, and it could put emphasis on things more than just kind of the research output, but the kind of the operational, I guess I'll say operational research, kind of emphasizing that with research software engineers and the processes that tie these systems, these facilities together and make deployment and integration easier. That's not always the case, but I think it's going to become more important for the future. And then the other high level thing I wanted to define a little bit was this integrated research infrastructure. So this is something kind of next in line, so to speak, after ECP, a kind of grand vision of tying these unique systems together and the software that's going to drive them, and having these high level workflows, IRI workflows on top of facilities. And so how we make all that happen. And in my opinion, this diagram on the bottom right is something I put together as, in my opinion, it's about providing systems to workflows and doing so through APIs and things like that. But not just, we should look at it from the perspective of not just achieving work, but also how we allow, software developers and vendors even, how do we allow them to access and test their software, against the systems more easily, integrating these DevOps workflows more tightly with the tools they use outside of the facility. So the common interfaces and services layer is going to be important. And then what is research software engineering? I guess this concept has been, I think it was formed maybe a decade ago now, if I recall. Someone can correct me if I'm wrong, but I wanted to highlight these pillars and the importance of what they're putting together here, and for the longevity of science output, and not just emphasizing papers and things like that, but how we reproducible science and the software that drives the science, and how important all of that is. It's an important field. And I also want to highlight how, continuous integration as a practice and DevOps on top of that are really important and vital to the software development pillar. Automating and recreating software and testing it and verifying its correctness and things like that are absolutely necessary. And then also the Exascale computing project is a superb example of embracing these things within its project timeframe. So emphasizing these software development, community training, policy. For instance, I mean, this talk that we're on right now was put together by ECP, so where that they at least contribute to the IDEAS stuff. So, and then the last thing, there's a link here for the software sustainability initiatives, but I'll have it linked on the back end of my slides too in a resources slide page. But all of those are looking at these pillars as well. Sustainability is an important idea, and it's definitely baked into this kind of research software engineering model. So just wanted to highlight that. I guess, are there any high-level questions about these high-level definitions or anything? I'll pause for a minute before we kind of dive into more of the continuous integration aspects of things. But
None, Brian, please go on.
okay, cool. So defining continuous integration and continuous deployment. Continuous integration, I think, most folks are probably aware of these practices, but it's ultimately about automating the integration of code changes from multiple contributors into a single software project. So it's just boosting collaboration and feedback time and the ability to test and integrate changes of software. And then you have that kind of backed by infrastructure to test within. So if you look at these GitHub and GitLab, they're platforms as a service these days. So you have your code repository, you define kind of the rules and the pipelines you want for when code changes come in, and then on the back end you have infrastructure that you use to actually run those tests and those changes against. And then you have this continual feedback loop around build failures and test failures. And then ultimately, after the CI aspect, you have the continuous deployment aspect, which is building on top of the continuous integration to automate the deployment of an application into the production environment. I won't be talking about continuous deployment so much here, but it is certainly something that can be built from later. But I think continuous integration is kind of the core key component up front, and then continuous deployment can be built on top of that afterwards. But all of those things come together into these DevOps ideas. And so I want to talk about trying to apply and making this easier in the HPC environment context, not so much the enterprise context. I think there's a good amount of difference in the requirements and the needs in both of those scenarios. So to highlight some of the challenges of adopting CI for HPC applications, when you use the cloud-based kind of platform as a service technologies, GitLab and GitHub, what you're provided by them in the cloud to do your testing is a general environment. You might be able to replicate the target environment in some cases on their back end, but in a lot of cases, you're not going to be able to do that. And so so it's nearly impossible to kind of, if your ultimate target is, say, Frontier or Perlmutter or Aurora, those environments are very complex and unique, and the hardware and the software. And so being able to, the tests you run in the cloud, especially if they're performance related, you're not really going to be able to achieve that or kind of confirm your performance in these general cloud-based environments. So we need a way to kind of tie in, this. So the concept here is, how do we tie in these systems or their environments fully into the developer's workflow? At the moment, it's pretty decoupled and not integrated. Often, you have to become a user at the facility. You have to, go directly to the machine, kind of pull your code base down, build it, maybe work with the staff, run your tests, and if there's any changes, you push them up, and then run your pipeline in the cloud and see how it integrates. But it's not the main point is it's not kind of tied in directly with this CI workflow.
So Ryan, there is a question here that I think is timely. Can you clarify what you mean when you say DevOps? Because apparently the term is used to mean many different things in different situations.
Yeah. So, taking development into operations. So, so DevOps, I guess, is the shorthand. But these, CI and CD are kind of some core components of the DevOps framework or mindset or tool belt. And so it's really about automating processes around software development, but that can also be applied to infrastructure. It can be applied to pretty much anything these days because we're driving everything with software. But it's taking development ideas and kind of automating development into the operations space through things like continuous integration and continuous deployment. Does that help?
Yeah. Okay. So there's another question, but I think we can take that later.
Okay.
Please go ahead.
Okay. So what do we mean by high fidelity testing infrastructure? So this is the concept that I'm kind of shooting for, and I kind of in my mind is a gap in this space. And so as stated before, it's currently difficult for research software engineers to automatically test, integrate, and deploy software into remotely managed computing facilities. And so in the Oscar case, these are remotely managed and provided, really big, robust systems. But there's a global user base for these systems. But all the software, a lot of the software is open source and out in the public space, and there's contributors from all over the world. And so integrating those kind of public repos directly, the CI workflows behind those public repos directly into the system is difficult due to security reasons and also kind of resource constraints too. So, we can't trigger a CI job for every change that happens directly on a production system. That's really, the production system's really there for scientific campaigns, and the time that you get on those machines is precious. And so a lot of the times you don't want to use those for testing or integration and things like that. So the cycles are precious, and we'll talk a little bit more about that later. But if facilities provided these high fidelity environments that were independent of the production system, then we can start to look at it like this, where we have these robust CI services, and that high fidelity environment is maybe more plugged into the CI workflow, and we can do these fully automated kind of CI workflows more tied to the upstream code base, and then you deploy to the production environment. And the details of that there's a lot of details that have to work in that space as well, but we won't go into that. But I do want to emphasize what we mean by high fidelity testing and how it could be useful if we had environments like this that were separate from the production environment and maybe provided in a more open space to developers who are trying to target these systems. So here's a high-level view of what a DevOps workflow might look like for these scientific applications. So you have these global community of developers. They have their central public repositories. They have their general public platform as a service backends for CI in those general environments. But then we can see this continuous integration loop against this high fidelity testing environment. And then this continuous deployment over to the production environment. And so, like I said, the specifics of the continuous deployment could take shape in different ways. Software is provided on these systems in complex manners. But a common method for both of these ideas across all the systems would certainly be useful. So if each site or each lab was interested in providing a high fidelity testing environment in the same way up to these these developers, we could provide a cohesive and more fluid kind of CI service across them. And this is just a high level view kind of outlining how we could tie that high fidelity testing environment into their code bases. So yeah, why can't we do this today? So triggering automated workflows from external systems is not a widely solved solution, particularly in Oscar. So they are, as mentioned earlier, these systems are kind of in a walled garden, so to speak. So people can access them, but integrating workflows from the outside is still being is not a completely solved solution. And so we have, in the case of software development, you have this global community of developers. They host their code on GitHub and GitLab. There's people from all over the world contributing to these code bases, and all those, not many, some of those users might be, they might have an account at OLCF or ALCF or NERSC, but a lot of the contributors do not. And so how do we bridge in changes from everyone into to test in these environments? There's definitely a security component to figure out, and also like I mentioned, the resource constraint component to figure out. And that's where, if we decoupled this high fidelity environment from the production space, the hope is that the security posture or ideas change. It's an open system, and it's put there for the use case of testing. And so we're trying to remedy these two challenges by pulling this fidelity environment over away from the production system. And so and so traditionally, as looked at in the other one of the other diagrams, you pull your code in, you build it, you run tests, and you work with staff, which can still be the case. But if we could try and put in some automation into these workflows, it would greatly help with efficiency. So I'll stop before I look at ECP stuff that we've done in ECP specifically. Are there any more questions? I don't see the chat, I'm sorry. So
it's all right. So there's one here. How do projects get resources, allocation hours, to run their CI workflow on the HPC systems you mentioned?
I'm sorry, can you say that again? So how do they do it?
How do projects get resources to run their CI workflow on the HPC systems that you mentioned?
Yeah, so for right now, it would just be a part of your normal, so how the Oscar facilities work, at least, is, you have a scientific proposal, you propose what you want to achieve on the system, it goes through this resource utilization council, they evaluate the need of the system based on your proposal, and then they grant you time on the machine. So there's no specific pipeline or request. There's no way to request, I want to use I want my allocation to be dedicated to the CI, to my CI workflow. It's kind of, you have to get a full allocation on the machine for your scientific proposal, and then within that you would use your some of your time for testing, depending on how ready your code is for the machine. Which, some of our long running projects may have a pretty good idea, but some of the new ones, certainly not, if they haven't actually, built their code for the specific hardware or the programming environments on these machines, it can certainly eat into a lot of the allocation. So the short answer is there is no direct way to request CI time on these machines. But that's part of the hope here, is that if we had these high fidelity environments, we could open that up. So folks could, there could be a direct pipeline for CI time, not just kind of scientific allocation time on the production machine, but also a separate independent allocation time for CI processes.
Thank you, Brian.
Yeah. Is there anything else in the questions in this time frame, or?
No, not yet. No.
Okay. Okay, so so now I'd like to take a step back and look at where ECP comes in. So these are some of the things that we've been trying to achieve within ECP to tackle some of this. So I'll give a little bit of an overview. of why these concepts are important to ECP, and then some of the tools that we've actually developed in ECP to try and help remedy this. So we can, why is DevOps important to the Exascale computing project? So the ECP has been focused on delivering Exascale ecosystem, application system, software, hardware technologies, and architectures to these diverse platforms. And each of these, you can look at the specs and kind of get an idea of how diverse and big they are. And we're, a lot of the folks are trying to get as much performance out of these machines as they possibly can. And in order to test your performance, you really have to, you have to have your code tested in that environment. And so that's one of the core drivers of this. And so the key initiative that we've been focusing on, particularly the team that I work with, is on streamlining the software testing and deployment. And so what we have done does not have that high fidelity testing environment. So part of the idea of that high fidelity environment is kind of due to what we have learned. And so what we've learned during the ECP project for software deployment, we've kind of seen that, okay, it would be great if we could decouple the CI infrastructure from the production machine, because we're running into these kind of security and resource constraints and concerns, and these concerns from the facility, rightfully so. And so if we can break it apart and just provide this resource specifically to the CI use case, it would greatly help. And so, and ultimately, we know that software developers targeting these facilities have difficulty bridging their development environment to the systems. And so our hope is to remedy that. And we did make progress in ECP, and we'll talk about that a little bit more in the next few slides. But we acknowledge that it's not, it's not continuous integration to the level that folks are used to when they just use the kind of the open cloud-based platforms there. So we're trying to make it more like that. Our hope is to make it more like that than it currently is. But we did make some progress, and we'll talk about some of that. So this is what our team looked like in ECP. We had two teams. There was a software integration team, and then there was a continuous integration team. And you can see how we were kind of stacked in this hourglass. So we, the continuous integration folks are focused on the infrastructure and tools that the software integration folks could use while they help the software technology folks and some of the packaging frameworks like E4S and SPAC. Sorry if you don't know what those are. I don't define them here, but they're ultimately HPC packaging tools and delivery tools. And so our combined purpose here is to provide infrastructure and support for integrating the software across these Oscar facilities. And it's important to acknowledge that we were kind of, we are trying to provide this common interface on top of each site to make the experience more cohesive. And this is an ongoing work in progress. And so one of the key tool, the tool that ultimately came out of this is the Jacomar CI tool, and there's a link to it here. And the primary goal is to provide access to powerful scientific test resources managed by facility experts. And when we say test resource in this case, we actually mean on the system itself. So there's this tool would get installed on the login nodes of the HPC resource. It would tie into a site local GitLab repository. So at OLCF, we have a site local GitLab repository where code gets mirrored down into. And then we attach this Jacomar CI tool to that, which ultimately allows these nightly pipelines to run on a machine. That's what we're shooting for. And so we have this tool. It's ultimately a custom executor, GitLab executor with some enhancements. enhancements are outlined here. Most of it is authorization focused. So we're ultimately able to run CI jobs as the actual user who triggered them, and so there has to be a user. You have to have a system user, and you have to have the user in the repository have to match. And so I would have a user in our site local GitLab repository. I would have a user on the system, and whenever based on how we configure the job would execute as me on the system. So part of the assurance levels of these systems is we have to know who's doing what, and that's the reasoning behind a lot of these enhancements. The other enhancement is it links to the actual resource manager. So Slurm, LSF, you can actually, there's variables that allow you to call Slurm commands or LSF commands. So you can submit a job to the scheduler to actually run as a part of your CI pipeline. So in a lot of cases, folks will build on the login node, and then they will do some testing, maybe a couple node, 2 node tests or 3 node tests against the machine by submitting it to the resource manager. And here is what we're working towards. So this is kind of a high level outline of the workflow for testing and deployment. So on the left, we've kind of seen a version of this already, but developers utilize kind of the platform of their choice, whether it's GitLab or GitHub. There's other ones out there too. They contribute code. You write kind of these pipelines and these CI tests and these rules based on the things you want to happen when a merge request is sent, and when a build is ran, when tests are ran, what kind of tests. And so really we're trying to balance the thing that software developers need to kind of understand is like where do the tests make sense, and then that's kind of the first 2 steps here. Within ECP, the third step, we also have this E4S, which is the Extreme Scale Scientific Software Stack. So it's a curated list of packages, and what it really provides a lot of standards for the software packaging. And so there's an onboarding phase to create a SPAC recipe. Then they also are the vehicle that gets shipped or that ships software to each of these sites. They plug into the Jacomar CI tool on each of the systems directly, and they're able to kind of run these builds and tests of the packages included in their list against the system. And then ultimately you get these facility deployments of a suite of software packages. And there's a dashboard out there, e4s.io, that shows the state of each of these E4S releases on the system. But this is what we're working towards in order to tie it all together to create a workflow. But again, it doesn't. We're not able to do CI to the full capability that I think a lot of folks want. It helps because you can set up an automated nightly pipeline, but we're not able to react to every merge request and run it in the facility environment. It's kind of decoupled from the normal flow of things, and it happens non-continually, honestly. So it's not really truly CI on the right side. It's a nightly thing or less is the best we can do or work towards at the moment. So, but we've based on some feedback, we want to work towards a more true CI capability at these sites. And I think we have to decouple the CI infrastructure from the actual system in order to do that. So yeah, why would high fidelity infrastructure help? I touched on that already a little bit, but having these open test infrastructure decoupled from the production system is really what we're talking about. And then we can start to explore truly continuous integration against the environment instead of what it's been so far. And so, yeah, to me, working towards that high fidelity environment is the first step. and working towards more true CI and DevOps, CI and CD within these developers targeting these systems. Okay, so the next I'm going to go over various CI scenarios, not necessarily just for the Oscar facilities, but a little bit more generally. And there's just a few slides for that. But before I go on, were there any other questions on any of the previous section?
Yes, Ryan. There's a question here. What does a separate HPC system for CI processes look like? Why is this better or more feasible than working on the production system, perhaps with dedicated Slurm queues?
Yeah, so you could do it. There's multiple ways to approach it. So I kind of abstracted the actual implementation of it. It could potentially be done with queues. In that case, you're still in, if it's just separation by queues, you're still in the production environment. And so you're still going to be limited by that enclave that you're in. So for us at OLCF, we run Frontier, and it's in the moderate production enclave. And since it's in that enclave, anything we do in that space is going to be limited. Even if there's a dedicated queue to CI, the workflows we can enable are limited by the security controls in that enclave. And so if we were actually able to take it out of that moderate production enclave and put it into the open enclave, then the security constraints change, and we can work towards opening up more true CI in that space. So that's going to be different at each facility, I would imagine. But the protections around the production system, whether it's a separate queue or not, are going to be the same. So, having a dedicated queue there for CI is certainly a great step in the direction, I think, because then you could allocate time, differently to each of those, to the normal batch queues and then kind of the testing queue. I mean, that's certainly a great step and not a bad idea. But I think really getting into, getting to where we want to do full CI, I think is going to kind of require this separation. And so, yeah. But you could even start thinking about, if you just have, I guess I'll go ahead and say we've been kind of speculating the idea of being able to do this inside of like a Kubernetes platform as well. So say you had a handful of nodes that mimic that's the same hardware as the target system. You take that hardware, you plug it into the Kubernetes cluster, and then you kind of use cloud native CI tools here. And then you can actually probably do more robust things with that. So the tool we developed out of ECP, Jacomar CI, it only works with GitLab, for instance. So it requires a site local GitLab repository specifically. Then you can mirror your code in from your GitHub or wherever else into that. And then Jacomar ties to that site local GitLab one. But if we had these cloud native tools, we could, and we have a basic proof of concept of how to tie in like a technology like Tekton. I don't know if folks are familiar with that, but it's a cloud native CI/CD tool. And so you could take Tekton and create these workflows with GitHub and GitLab directly with the code bases out in the public, not requiring that site local mirror. And so, but I don't know. So yeah, Kubernetes, a lot of these facilities have a Kubernetes cluster sitting next to the machine. And I really like the idea of putting these extra services there as much as we can. So.
Since you mentioned GitLab, that's the next question here. Is Jacomar capability available in GitLab Community Edition? If it's separate from GitLab, with a pull will a pull request be opened to propose Jacomar integration into GitLab?
Yeah, so it's fully compatible with GitLab. I think I'd have to talk with our main, I don't know if he's here, but Paul Bryant could answer that question better than I could. But I can certainly get an answer. If we can write that down, I can get an answer. I don't think it depends on the edition at all. but we work closely with GitLab, and we constantly develop against changes that are happening at upstream GitLab, but it's it's compatible with those.
One participant just made a comment here that works for him in the CE edition in the chat.
Okay.
So just another question here. I think we have a little time here. That's from Alfred Tang. Is CI currently being deployed in ECP projects?
Yeah, so if you're an ECP project, it is not ready on Perlmutter yet. It will be ready on Aurora. We have it for Crusher at OLCF, which is the same environment as Frontier. And so, yeah, if you have an ECP project and you're looking to do this, you can reach out to us and we can onboard you into the system that you're targeting.
What about Sunspot there at Argonne?
Sunspot has I'll have to follow up with the site coordinator who works at ALCF and get a more up-to-date status on that one. But
okay, keep going.
Okay, is that all the questions for this case?
Yes.
Okay. If there's any questions about trying to apply this at a specific facility, I'm happy to follow up with folks about the state at those. It's been a work in progress across each site, especially with the new systems coming online and all the changes happening. So, but happy to talk with folks. Okay, so I'm going to take a step back and look at these kind of the high level picture of these common CI scenarios. So on the left, you kind of have is kind of the generic version of this, the non-HPC version, I guess I'll go ahead and say. Where you're totally, you're good with the cloud-based CI systems provided to you by these platforms as a service, GitHub, GitLab, whatever your tool of choice is. You're okay with the containers or the VMs and the things that it gives you behind it. There is still a cost to those; they're not free, but those are fully in your control. You control the configuration of them, and you do what you can. As you move to the right. So the Oscar model is the one in the middle. This is what ECP and the Oscar facilities. This is what we have to do. We have this site local mirror, then we attach that site local mirror to the facility system via that Jacomar CI tool. And then on the right is more along the lines of what like NNSA labs would do. So Sandia, so the Tri Labs. So what they would have, and maybe some other folks, where all your code development is happening in-house. So you have your own proprietary code, you have your own system, your HPC system, and you're able to have all your CI workflows are inside your institution. So everything from the repository to the system you're targeting, it's all within your institution. And so that's kind of those are the three models that are out there that we have seen a lot of. But the two on the right are more HPC centric. You have a system that's in your right underneath you, your repository is right next to it, and all the contributors, you're all colleagues, staff at the same institution, and you're working on the same code base. So that's that right hand one. And then in the middle, like what we have for Oscar and ECP, is we have these, the software is being contributed to by people all over the world, but we're trying to figure out how to take all those code changes and test them on a system that is provided by a facility institution to the world. And so, yeah, we'll dive into just a little bit more metadata about these three scenarios. As I mentioned, scenario A, everything is in total control by the code owners, and it's all on public general environments. Scenario B, the infrastructure for the code base is split from the target system, and so the boundary, the institutional and security boundary there is really important, and kind of it's what sets the bar into what you're allowed to automate and how you're allowed to automate it. And so that's where the troubles come in when we're trying to do CI directly on these production systems. is that, that boundary line really starts to show, because you're limited on how much you can automate and how often you can test changes and things like that. And then on the right, when everything's in the boundary, it's, you're not bound, you're not hitting that that line. You're already inside, and you can kind of, you're just it's just an agreement between you and the system admins. And so the institution owns everything at that point. And so Jacomar really fits these two scenarios on the right, as mentioned before. So it extends the security model and user controls of a facility managed GitLab server to the CI/CD pipeline. So that's that site local mirror instance. It's ideal for multi-tenant HPC systems. So you can have it installed on the login node, make it available to projects in your site's GitLab repository, and then allow users to use the HPC system for builds and tests in their CI workflow. In the future, there might be other options that exist or technologies that help us. Say if we did, if the Kubernetes idea turned out to be a good one, we were able to work towards that, and maybe Jacomar is still applied in certain scenarios, but maybe we use these cloud native tools in other scenarios. So there's various models and ways this could work out in the future, just depending on what we do with the infrastructure and how it can be provided. And so why is post-EC important? Ultimately about, carrying forward a legacy. And so keeping this momentum, before ECP, I hadn't really heard CI be talked about, or even thought about CI services at facilities like this, for the user base. I think ECP really kind of brought that idea into the light more. I'm sure it was discussed and kind of thought about by folks or wished upon by developers and things, but it was never, it was never really a priority out, before ECP. And so now, ECP really prioritized these ideas, and we made progress. We were able to put time into this Jacomar tool and kind of integrate workflows directly on the HPC systems, which is a step in the right direction. And so we just kind of need to learn what the gaps are still, and try and keep that momentum. And then further, it's ECP's ability to bring the facilities together around new ideas, developments, and achievements. And so the fact that we could, that we had operational staff from each site coming together and agreeing that these were good ideas, and we're going to work towards implementing them, and the security folks from each place coming together and figuring out how to make help us make these things happen, and that's continually happening today. It's as the systems change and the requirements change, we're having to kind of adapt, but we have points of contact, and we have it's this nice layer across all the systems, ECP is. And so I really like to highlight that. I think it's important. It's going to be important for the sustainability efforts. It's going to be important for the IRI efforts. It's going to be important. That same mentality is going to be important for future things. And then further, as mentioned earlier, the emphasis on research software engineering and putting time into these processes that make software more sustainable, reproducible science, reproducible software, correctness. And, if we can, making testing easier and more of a first-class service at these sites will just benefit, the future of scientific application development and scientific output and everything. So. And then, just to follow up on that, what we're talking about fits, in my opinion, it fits this IRI, these practice areas, right? So if you read some of the text here, DevOps and continuous integration are they're about that, right? There's other things services out that fit this too. Obviously, it's supposed to be a wide kind of net, but I think CI in this space makes sense. So, if continuous integration services at each facility could be thought of in this IRI context, it might help with the momentum and keeping this going. So in summary, Oscar facilities provide unique and powerful systems, and they're going to require robust integration mechanisms. And we've scratched the surface with an ECP, and we know it's important. This is how do we, we can always make things better, and we can always try and provide these new services. And I think the CI component is something worth highlighting and bringing attention to. And then IRI and software sustainability initiatives are on the horizon. And CI capabilities will be important for both of those. And so, and working towards this fully continuous integration service on these Unix systems, we ultimately need the facilities to kind of prioritize these ideas, and linking it to IRI may help us. But again, these tools and ideas are not only for the Oscar systems. I know I was pretty Oscar system centric here, but they are applicable in other HPC facilities, and they are useful. And so if anyone has a system that they want to enable CI services on, and it's a multi-tenant HPC system, there's tools that can certainly help you, and start by looking at that Jacquemart CI tool for sure. And we're happy to, we plan to keep that tool going post ECP, and we're happy to work with folks on things. So. And here's just some links that I thought would be useful for folks. So there's the continuous integration documentation there. It kind of goes into the details, the administration and the setup of the Jacquemart CI tool. Obviously, there's a Better Scientific Software site, which is fantastic. There's an IRI presentation from Ben Brown, the Oscar Facilities Director, to give you a better idea of the IRI stuff. GitLab and GitHub docs, their general docs are wonderful. There's a research software engineering paper, which I found really a great read. And then this idea of research ops, which is highlighted in this other paper, and those are folks from IBM. And then software sustainability seedling projects. There's a link in a HPC Wire article about those. So if you're interested, you can kind of use that as a springboard to read more about. But I think that's all I had. I think that's my last slide.
Okay, thank you, Ryan. So let's see here, I have questions. Howard, you had your hand raised for a while. Would you like to ask directly, please?
Sure. So this is a great talk, Ryan. But I guess I'm one of those people who's been trying to use this GitLab CI stuff for now about 3 years. Our project is stuck in slot B, or slot 2, where in particular it's the OpenMPI project, which has been around many more years than ECP. And this GitLab CI infrastructure with Jacquemart runners is very promising, but unless something's changed, one big issue in slot B is Atlassian does not support updating on pull requests into these public GitHub repos, good or bad state, from the results of testing via Jacquemart runners on a mirror within a local facility. I can do a postmortem where once the commit has been merged into the branches of interest, then the mirror will get updated. Then that will trigger the GitLab runners. But unless something's changed, even the most expensive platinum versions of Atlassian don't support a feature where you can actually pull automatically, like for instance you can with Jenkins, pull request contents for an open, in Atlassian world it's merge request, but in GitHub it's pull request. So that would be a nice thing to get fixed, but if we can't do that, this post-mortem thing is okay. Another question I had is more for anyone from JLSE. Are we going to break free from JLSE at Argonne so we can have Jacquemart runners on, for instance, Sunspot? Or will we get a memo about that? Because right now I double checked. I went to my JLSE GitLab instance, and I only see Jacquemart runners available on the JLSE dev cluster.
I don't know if there's anyone
One
here.
was not so much a, well, I guess there was a question. Does anyone know if the most recent versions of GitLab can be configured so their CI will actually see open pull requests on the repo they're mirroring GitHub somewhere else?
I don't see any answer to that. So let's see. If for the sake of time here, Howard, let's see. There's another question here. I think someone is commenting, just a second here. So another question here. In the past, Ryan, people could do pipelines without CI. What is the advantage of using CI now?
In the past, people could do pipelines without CI. I'm not sure I totally follow. So what do you mean? Is the person willing to speak, to maybe add a little bit more context?
Alfred? Could you unmute Alfred?
Yeah, I'm not an expert in this, but seems that when I was doing workshops and seminars and stuff like that on pipelines, nobody actually told me about CI, and so I assume that it is something that you can do without when you're setting up the pipelines for your workflow.
So yeah, maybe there's a mixing of pipelines, I guess is maybe an overloaded term, but we're specifically the pipeline here is a what you define. So you build a CI. So CI is kind of a concept and an idea in order to automate testing of code. But in order to do that, technically underneath you build what is called the CI pipeline. And so those are just kind of the rules and the stages you set up for. So when a merge request comes in, you have these rules and these stages defined in your pipeline for what happens when that comes inside and runs. So what tests run. But there's definitely pipelines for like workflow, like non-CI workflows too. But here we're specifically talking about pipelines within the continuous integration context. Maybe,
Okay,
I don't know.
all right, I get it now. Okay, thanks.
Mm-hmm.
Ryan, okay, so let me see here. Slaven, would you like to ask your question?
Yeah, sure, very quickly. First of all, Ryan, thank you for all the help that you provided to our ECP project. It's much appreciated. I don't know if you had been in contact with PNNL folks from their research computing division, because they did most of the continuous integration support for our Exascale computing project, and they had some very crafty solutions. So maybe sharing experiences with them would be helpful. And I also know for a fact that Idaho National Lab has developed their own internal CI testing, CI continuous integration, continuous development testing tools. And most of them are Python based, if I am not mistaken, and under open source licenses. So that might be another resource that you guys could use.
Yeah. Thank you. Yeah, thank you for sharing that. That's a great idea. I mean, the more we definitely can't be and aren't the only folks thinking about these services on these systems. And, there's other labs out there, that have unique systems and environments and things as well. I don't know how unique the Oscar situation is compared to these other situations, but I'm sure we share some common general issues where you have these really big public repositories with global contributors, and then you have a system that is provided with this boundary, right? And so that boundary is really where it becomes difficult. So I don't know if Idaho and then would fit into this scenario C more. In that scenario C, it kind of becomes a little bit more. It's a little easier to provide things to folks targeting that system, but but either way, there's definitely things we can learn and talk about, I'm sure. So
what we did with the ExaSGD project was A, B, and C here. So all of the above. And I think it would be a good idea to have perhaps a more technical meeting and share the experiences and see what has worked in the past and what hasn't.
Absolutely.
We tried, many of us tried locally to address the lack of ECP-wide CI resource. And we all came up with some solutions that were sometimes patchwork solutions, sometimes a little bit better, but it would be good to pool resources together.
Absolutely. And you guys are, I often use you all as a highlightable project who has adopted CI. So,
So Ryan, so I see questions here in the chat, but I think we'll follow up with folks you know, and
Yeah.
later. Just take a final question here for the sake of time. What do you think about the possibility of having a CI-focused facility, something similar to what is done at the University of Oregon, and just doing the current testing at facilities, but having clear ties between the big facility systems and the CI testing, which would be a smaller facility?
Yeah, so the Frankenstein cluster at Oregon is a cool idea. The thing that I worry about, I guess, in that scenario is the disconnect of state. And so, you know, is the environment, you know, so you know, I guess if you have the hardware, that's a step in the right direction. But then there's also the kind of the programming environments and you know, the system level software. So keeping that in tune with. So if they have a small frontier-like cluster in their Frankenstein system, you know, is the system software, is everything in line, right? Does it match? Do the environments match? And can you fully trust what you're testing here to actually be reproducible here if they don't match? And so we kind of ran into that actually locally, because we have an open system called Ascent, which is a small sister cluster to a Summit. And that's where we originally started doing CI, but they're in two different enclaves. And this will happen, you know. So in the case that's actually a kind of an example of a high fidelity environment, because it's a small environment in the open space that matches the larger production system. But the issue we run into, and that we would have to acknowledge and try and remedy, is that they become out of sync. And so the system software on each and you know, the compilers and the versions of things that are available in one system don't match the other, and so you run into all sorts of issues when that starts to happen. So it's a step in the right direction, because you have that hardware available more open, but the software environment becomes the next level of concern. And that's where maybe, you know, like containers from vendors, like, so if the Cray container was able to be kind of shipped around to these environments, then, you know, then the environment becomes more portable, and you can apply it to these testing infrastructures. So that's something we can, you know, that maybe Cray's looking into. So.
Okay, thank you, folks, for all the participants for joining us today. Thank you very much, Ryan. So there are still, I think, some questions here that I'll ask you to take a look later. Okay.
Yeah, and I have my email here too, so I'm happy to talk with folks over email.
So I have the chat here and all that. So follow up with some folks here that were more specific questions. Thank you all.